Hello, my name is Axel Scherer. I will give you a quick introduction into UVM for System Verilog. This is the first in a series of short videos that cover the basic concepts. The target audience are both designers and verification engineers that deal with IPs, system on a chip, and system development. So why do we need UVM? We've been using Verilog for over 20 years now to model hardware devices and also to some degree to test them. But as complexities of these devices have increased, so has the verification effort. And Verilog is just not good enough anymore to verify these complex systems. So one path to solve this problem was the introduction of System Verilog. Now, System Verilog is not just an incremental increase over Verilog. It is a significant addition, right? And it's much more than just a few language extensions. System Verilog adds a lot of dimensions to the language. Now, let's start with the legacy HDL, Verilog. That's a great thing. You start with something that you're familiar with. And it's, of course, fully intentional. So you have a good footing. But the first step of the addition is object-oriented programming. So you model your verification environment in a dynamic way, you allocate objects and all that kind of stuff. So this is very orthogonal to your modeling of your hardware device, right? So that alone is a big deal. On top of that, you add specific concepts related to verification, such as constrained random test generation. And once you introduce randomization, you need something to measure it, such as coverage and things like that. So these are just a few of the aspects of System Verilog. There's a lot more. The problem now is with all this space and all these dimensions, how are you going to build your verification environment? If you just do your own thing, you're probably going to end up in chaos. And that's exactly what UVM tries to address. It performs a standardization of how to build your environment, right? To master all this power, right? How to build your test bench, how to generate tests, how to collect coverage, how to introduce your scoreboards and all that stuff. Let's do it in a same way, in a standard way. And the way this standardization evolved is basically by incorporating all of the best practices that have been developed in advanced verification over the last 10 years and more. One of the primary concepts is reuse, which is essential for complex verification environments. Now, talk is cheap, right? We can do videos like this, write a lot of papers, books, guides and all that good stuff. But that's not going to be enough. Human nature, we will stray from the recommendation. So the cool thing about UVM is that all of this wisdom is absorbed in a class library built in System Verilog. So here you have a high level of abstractions. Your components can be derived from base classes and things like this. So a lot of the IP from the best practices is embedded in the UVM class library. And just by using that, you're already way ahead, right? You have a lot of pre-verified components. You have much more functionality than basic System Verilog. That's just not in the language per se. And all of this is really customized to improve your verification productivity. Now, if you follow this class library in the UVM recommendations, you really have a powerful environment. And you join the large ecosystem of the growing user base of this methodology. On top of this, it's of course not just a standard, it's an open standard and it's vendor independent. So UVM in a nutshell is basically containing all these different degrees of freedom you have with a massive language like System Verilog and distilling it down to a standard way of using it to building a verification environment. Right? This way you can interoperate between your teams, between your staff and the whole electronic ecosystem. In the next couple of videos we will dive into details of the subcomponent and build it up. We show you code and give you some demos. You can find these videos either on this YouTube channel or at support.cadence.com at the video library for the Incisive Simulator. Have a great day and talk to you soon.